Hey guys, welcome to our channel Coders Arcade. This is Ashan David, and in today's video we are going to talk about the insertAtPosition function in linked list. So we have already created the other videos on linked list. We have already created 2-3 videos on linked list. So if you haven't watched those videos, I will give the link of those videos in the description below as well as in the I button, so you can go ahead and watch those videos also, because in those videos I've already explained you what exactly is linked list and how to write the first two functions for this linked list. That was insert at head and insert at tail. So we've already discussed about inserting the position, inserting the node at the head or at the position at the particular tail. Now in this video we're going to focus on how we can do insert at particular position. That means some specific position. We've already discussed how to insert any node at here at the head, or we have already discussed about how we can insert any node at the tail. Let's see what happens if I want to insert any particular node in the between, like in between these two nodes. How you will do it. So we are going to write today our insert at position function. Let's talk about this, guys. And to do insert at position, first of all, the first thing that you would require here is that you require here a temp variable. So basically temp variable will start from here. It will go till that position. But how you will go till that position? Just like in arrays, you have different indexes, right? Indexes starts from 0 in the array and it goes till the size -1, right? But in linked list, we don't have official concept of indexes, and that is the reason why here I'm going to assume that we are at this index 0, 1, it is going to be 1, 1, 2, and then here 3. So this is going to be the indexes for this particular node. Okay, now what we're going to do is we're going to start our temp from there, and wherever index I want to specifically, just by saying the index I want to insert something, then what I'm going to do is just give the position, and automatically it will take that index and it will do the job of inserting the tail, inserting the particular node at that particular index. So to do that, we will create a function called as insertAtPosition. And this function is going to take 3 arguments, like 3 parameters would be there here. That is going to be the position, the value, and then the head. In previous 2 videos where we have did insert at head and insert at tail, there we have taken only 2 parameters. So basically 2 arguments were passed, that is head and the value, because at the head a value to be inserted and at the tail what value to be inserted, that's all. But here this function is going to take 3 arguments basically. One is going to be where the head is present, another is going to be what the value is, and the third one is going to be at what position you want to insert the particular data or the node. Alright, so now to do this, first of all, as we know, because we are traveling to some particular point, just like insert at tail, we have to travel to that particular index. And how I can do that? So to do that, what we're going to do is we are assuming already that it is 1, 2, 3, 4 and so on, like indexes, but you don't have to specify this into program. I'm just hypothetically taking this for my understanding, and then I'm going to actually use this. And to do this, we are going to take that third parameter, right, that position parameter. So I'm going to say POS, position, equals to, now I'm going to take let's say some value, let's say I said 2. Let's say at position 2, I am going to insert some particular node, right? So let's say here, that means here at this particular index. So I'm going to put some particular data here, there. And to do that, the question here is how to reach till that particular index. To reach this particular index, if you remember, in insert at tail, we used a while loop. A while loop which was traveling from the beginning. We created temp variable, and our temp variable started from the head, and that was going till the tail with the help of a while loop. While we said that while temp of next is not equals to null, that means it doesn't become null, keep on doing temp equals to temp of next. We have already discussed about this in our insert at tail video, so you can go ahead and watch that as well. There we have properly explained that. Now same logic we will be applying here, but instead of using temp of next equals not equals to null, that was the condition for the tail. Instead here we are going to create a while loop where the condition would be decrement the position and increment the temp. So at some point of time, our while loop would look like this. See, while the position POS is like, it's not like position, it would be like this. See, it would be like minus position, while minus position. In that case, do temp equals to temp of next. Well, this is going to be our condition basically, guys, right? So what happens here is that the position decrements, the temp increases. At some point of time, the position will become 0. And what happens then? The while loop stops. And you reach at that position by decrementing the count in the position, incrementing the temp. So those many number of times the temp moves forward. For example, the position is 2. So we created our temp variable here. So this is our temp. Now I decremented the position by 1 and incremented the temp towards this side. Now temp came here. Decremented this again till it becomes 0 and the temp reaches at the correct position where I want to insert the node or the data in this case. So position was 2 and our temp is reached at the 2 index. So this is going to be the logic to make our temp travel from the head node to the particular index node. And once you reach there, you can create the node, right? So let's create the node here. I'm going to create the node right here. This is our node and I am going to take the data, let's say 15. And this node also will have some address, let's say 3172 I'm going to take, okay? And now as soon as I say I created this node, this will be null, of course. So what I need to do is, temp is right now here. What I can do is that I want to, let's say in this scenario, I'm going to take the temp one step back so that it's easier to understand. Here is our temp. Right now my temp is right here, okay? And then what I need to do is that I need to connect this node in between this. So what I need to do, I would need to break the link from here like this. And once the link is broken, what I'm going to do is I am going to reconnect this broken link like this and like this. And to do this, I need to change this to this number. That means here, instead of having 2780, I should take 3172, right? Correct? So this node will get connected to this. And here, instead of null, instead of this being null, I have to write here 2780, right? Well, this is how you're going to do it. There is one catch here, guys. And what is that catch? The catch is that you will, once you reach that temp, while the loop finishes, this loop finishes, what you can write next is that this is your end, right? So what you can do is here is that you can say, first you have to pick this value. Always remember, first you will pick the next coming value. Otherwise, if you lost this value, what happens is that your program won't work. Why? Because if this position is only gone, there is nothing to store here. That is the reason why you will first say n, which is our new node which we created, this node, n of next pointer will be pointing towards where the temp of next is pointing. You understood? So where the temp of next is pointing. So temp of next is pointing right here. That means this will keep the position, whatever is stored here. Which means first what will happen? First this wire gets connected. First this wire gets connected here. And once this wire is connected, now I can say temp, you become this n itself. That means temp of next equals to n in this case. So next thing I'm going to write here is temp of next equals to, I'm going to say as n, which is going to actually connect the node. And this is going to be the logic. One thing you should always keep in mind is that by chance, if you wrote this first, so always remember, first you have to write this and then only you can write this. By chance, if you wrote temp of next equals to n first, then it would be wrong. Because why? If you said temp of, let me just explain you again here, right? Properly, you see this is our data, right? So if you say here, this is your temp. If you first said temp of next equals to n, that means instead of this, you stored 3172. So first this wire will get connected, but then you lost this value. This value is forgotten because temp of next was holding it. So first you want this to take the value. So right now this will not work. This will be always be null and you cannot connect it anywhere. And that is the reason why this line always has to be written first. And then only you can write this, right? So always remember this, guys, in this logic. I hope that this logic is very much clear, right? Now let us move on to our VS Code and understand how the code is working. So this is your insertAtTail function. Now we have started by creating our node here. So there you go, node star n equals to new node, val is been passed. This is the constructor call. Then we are checking if the head is null. So basically this is your insertAtTail. Yeah, so this is our void insertAtPosition function, and in this case we are taking three values, as you can see: insert int pos for position, int data, and node star ampersand of head. Now we have done here call by reference. Here you can see that I've taken the head reference here. So you already know what is head reference, right? We have already talked about call by value versus call by reference. If you have not watched that video yet, I will give the link in the description below so that you can go ahead and watch that video as well. That's a very important video if you want to understand how this is working, or how you can use a double pointer in this case. You can understand it from there. Okay, so that's a very small and very basic concept. You can just watch that video there and you can understand this. But here we are taking three parameters: position, data, and the head. Okay, so now what we are going to do here is we are going to create a new node first. Now don't worry about what this size is right now. I'm gonna tell you what that size is coming from and what is happening there. So first I'm gonna create the node. So there you go. I have already created the node. Node star n equals to new node. And then what is going to happen is I'm gonna check here. What if the position is lesser than 0 or greater than the size of the linked list? Then in that case, what will happen? It is going to be invalid, right? How this size I'm calculating, I'm gonna tell you. So you just wait. I'm gonna come to that point also. First you understand the logic of how I've written the code. Then I'm gonna tell you how to calculate the size at the last. So I've just created a size variable which is actually calculating the size of the whole linked list, so that this position argument could be verified if the position is working correct or not. What happens if the length of the linked list is 5 and the user entered 25 as the position, but the node doesn't, those many node doesn't even exist in the linked list, then what happens? That is the reason why I have calculated the size of the linked list and then I've checked it here. If the position is less than the 0, that means if the position is entered as negative value, or if the position is greater than the size of the linked list, then you just print invalid position to insert. So you cannot do insertion there. Okay, that's one point. What happens else if the position is equals to 0, if the user enters position as 0? In that condition, what will happen is the insertAtHead function will work, or if you don't have this insertAtHead, what you can do is you can just say head equals to n. So head, you start pointing towards n, the newly created node itself, and that will be insertAtHead. You got my point? So you can do that as well. We have already understood this in our previous video, so you'll get the context from there much more easily. Okay, and then else. In the else part, this is our main logic that we have written here. Okay, so we have already created our node. Now we have created the temp variable starting from the head, right? So I said node star temp equals to head, as we discussed in the logic that first attempt will always start from the head, and that is the reason why I am giving the head reference always. Then, as I explained you the while loop, while minus pause, and we are going to do temp equals to temp of next. So position will get decremented while temp is getting incremented. This way your temp will reach at that particular index, and once it reaches there, remember these two lines just now I explained? N of next, that means newly created nodes next, will first fetch the value of the future coming node, that is temp of next. And then only temp of next will change to n. Understood this, guys? This is very much important. Then only your function will work. If you write this first and write that later, your function will go into recursion. which we don't want, and that will not happen. Now let us see for the last time, let us see the size variable, how the size variable is working. So basically the size variable is working by, I have created the function here called as get current size, and here it is taking just the head. So because now we have not passed the reference of the head, I can move the head in this case. So I've created the size variable and I've taken it as 0 because it's auto, it will contain a garbage value, right? Its storage class is auto. So while head is not equals to null, keep on traveling the head to the last node. Now in this case I can move the head. We've already discussed about this many times in a display function and an insertAtTail function, right? So we can just move our head to the last position and we can increment the size. So the size is calculated and it is kept into the size variable, and at last size will be returned. So now before I start this function, I just created an int size variable and just calculated the size by just calling that function here, which gives you the size of the leg list, and then later on position can be just compared with this size. I hope so. This is very much clear to you, all of you guys, right? So this is going to be the code. Now for the last time, let's run this code and see how it is working. So basically here there will be no space here, but yeah, it is correct. It will work fine. So here I've done some insertAtHead, then insertAtTail, and then displayed the list. Okay. So it is going to be like that, and then I said insertAtPosition. I have said first 3. Now 3 nodes are not even present in this linked list. So what will happen? It is going to print invalid position entered, because you see, first we said insertAtTail. So 0, 1, 2, 3, 4. So in this case, see what happens here is that, let me just make this space back here. Might interrupt the whole thing, but yeah. See, when we run this program, what happens is that you can see that first there are only 2 elements here, you see, 40 and 50, right? Then it is printing null. So when I said 3 here, because 3 was not only a position, what happened is invalid position to insert, printed. And once I said 2 means here 0, 1 and 2. You can see at that position 1000 is basically inserted. So working fine, right? So well, this is how your output is look like. Now you might think that why it is going like this, why I have said so many insertAtHead and so many insertAtTail and it's not working. So if you remember in my previous video, I explained you what happens when you don't pass the ampersand of head in this case. So you see, an insertAtHead, I did not pass the ampersand of head, and that is the reason why it is not showing us the full length. So now you can see that when I run this code, now everything will work fine and it will run exactly perfect. Right guys? So well, this is how your linked list concept works. So well, that's all for this video guys. I hope that you have understood this video well. If you have liked this video, tell us in the comment section below. And thanks for watching. Don't forget to like, share and subscribe to our channel Coders Arcane, and don't forget to press the bell icon so that you won't miss any future updates. Well, this is Ashank David signing off. See you guys in the next one. Thank you.